All right, we ready for a challenge? The most difficult type of radical equation is when you have a radical on one side and not only a variable but also a number on the other side, which means we're not just going to get an x squared, we're going to have to square this x minus 3. So first make sure your radical is by itself, which this one is, and then we're going to square both sides. But notice I'm putting this in parentheses and squaring that, and then squaring this side. On this side, the radical cancels out with the square. That's no problem. That becomes 5x minus 1. But to deal with this, I have to do a little extra work. That's actually x minus 3 times x minus 3. You can use whichever method you've learned for dealing with that, but you have to make sure that you get all 4 combinations of multiplication. So x times x, x times negative 3 times x, and negative 3 times negative 3. I do that with the area model. It's my way of visualizing to make sure I've gotten every combination. So x times x gives me x squared. X times negative 3 is negative 3x. Same thing down here. This is x times negative 3 again, so negative 3x. And then negative 3 times negative 3 is going to give me positive 9. Now, these two terms are both x terms. They're the same, so they can be combined. So this gives me x squared minus 3x plus 9, but I can combine these to give me negative 6x. So that's x squared minus 6x plus 9. So that was a lot of side work to go on the left-hand side right here. So I have x squared minus 6x plus 9 right there. So that's the quadratic equation. Let me rewrite what I've got. I'm going to have to move things towards my quadratic. So I want to subtract a 5x from both sides. And then I also want to add this 1 to get rid of it. So over here. So I put that all together. This goes away and I have equals 0. And on the left now I have x squared minus 11x plus 10. All right, so we had to do some extra work, but now it's really no harder than the previous two. So I'm looking for a pair of numbers that multiply to give me 10 and add to give me negative 11. And that's just negative 10 and negative 1. So I've got x minus 10 times x minus 1 equal to 0. And that's going to then give me x minus 10 equals 0, so x equals 10. And x minus 1 equals 0, so x equals 1. Of course, though, I do have to check my answers. And by the way, it's totally okay if you run out of room and need to do this on a separate sheet of paper. That's what I'm about to do. So, checking. I've got my original equation. So x minus 3 equals square root of 5x minus 1. I'm going to put my 10 in there. 10 and 10. 10 minus 3, of course this is a question, right? I don't know it yet. 10 minus 3 is 7. 5 times 10 is 50, minus 1 is 49. So the question is 7 equal to the square root of 49? It is, and so I'm going to keep this first answer, because when I plugged it in, it gave me a true equation. I have to check the other one as well. So x minus 3, just replacing x with a blank, with a parentheses, and then equal to the square root of 5 times x minus 1, question mark. So I'm going to stick my 1 in there. 1 and 1. Now, here's where things get weird, because 1 minus 3, that's negative 2. And that's equal to a square root. That's a problem. We can't take a square root and get a negative. 5 times 1 is 5, minus 1 is 4. Is this a true statement? No, because negative 2 on this side is not equal to the positive 2 that we get when we square root 4. This is not equal, so this is a no. So we go back up here to this one and we cross it off. That again is an what's called an extraneous solution. So our one true solution is x equals 10.